Assalamualaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. Children, will continue with this chapter mensuration. We have already completed 2 exercises. Now this is about the third and the fourth exercise. The third exercise is basically about surface area and lateral surface area. Okay, total surface area and lateral surface area. Now I will first explain what this means. So now you see these solid shapes. So we are going to learn only cuboid, cylinder and cube today. Okay. Now here in these, if you look at this, you can see that it's a solid figure, right? Like, if you talk about a cuboid, you can imagine it to be your own room, the room in which you are sitting. It's usually cuboid, right? Or either cuboid or a cube, isn't it? So in these things, you can see that there are four walls surrounding you, and there is one ceiling on top, and there is one floor at the bottom, right? So the total surface area is actually the area which is like the area of all the four walls surrounding you, plus the area of the floor and the area of the ceiling. That is what is your total surface area. Now when I say lateral surface area, that is nothing but the area of just the walls surrounding you, not the area of the floor and the ceiling. Okay, the floor and the ceiling should be excluded. It's only the four surrounding walls we need to consider in lateral surface area. Okay, now here if you look at the formulas, now we come to lateral surface area of a cube. So you know that cube has all the four sides equal, right? So now if I talk about the walls of a cube, the four lateral surface area is just the wall surrounding it. The four walls, if I talk about one wall, I have the area of one wall to be L into L. Let us say this is L, this is L. Okay, L square. L square is area of one wall. Now if I talk about lateral surface area, I have four walls in together, so it will be 4L square. Okay, so that's how I get this formula. Now when I talk about total surface area of a cube, I have one wall on top at the bottom also, right? So we can consider it something like that, right? The ceiling and floor are also considered as some walls only, a face, isn't it? So you have two more walls being joined. So that's going to be 4L square plus 2L square, which is 6L square. Now coming to the cuboid. Now cuboid has the length with cuboid has a length, breadth and height. All three are different, right? So here in this case, what happens? If you think about yourself in a room which is of a cuboid shape, you have a different length, different breadth and different height. Now you talk about the floor of the room in which you are standing. The floor is actually length into breadth. I can consider it as a length into breadth. See, let's say this is the floor. Okay, so this is the length and the breadth. And let's say there is the height of the room is something like h. Okay, now I will be having something like this, isn't it? So this is how my figure will be, right? This is how my room will be. Now when I talk about a floor and the wall, they both are involving length and breadth. So length into breadth into plus length into breadth. So 2 into length into breadth, right? 2 length into breadth. Then when I talk about this side wall, let us say this wall, okay? This wall is involving breadth and height. So and this side also will involve breadth and height. So 2 breadth into height plus 2BH. Then let us talk about the front side and the back side wall. That is involving length and height, isn't it? So that's going to be 2L into H and L into H. So plus 2LH. So now here you see you can take out the 2 common and you end up getting LB plus BH plus HO. That is your total surface area of a cuboid. When you talk about a lateral surface area, I should not consider the base and the top, right? The base, floor and the ceiling should not be considered. So floor has got length and breadth, and down also length and breadth. These two are not supposed to be taken. So LB is not supposed to be taken, right? Apart from LB, you have 2 breadth into height plus 2 height into L, H into L. So there 2 and H are common and you get 2H L plus B. See, you can memorize this formula, or understanding is also restored. Now let's come to the cylinder. So cylinder is something like this. It looks like this, right? So now when you talk about a cylinder, this is the radius and this is the height. So lateral surface area of a cylinder is 2 pi r h, and the total surface of a cylinder is 2 pi r h plus r. So you can just memorize this. So in 9th, 10th and all, we will explain you how these formulas are derived. Okay. So right now you can just quickly memorize these 6 formulas. Alright. Now come to exercise 9.3. It says there are 2 cuboidal boxes as shown in the figure. Now if you look at this box A is cuboidal, box B is actually cubical, right? Because you see 50, 50, 50, all the sides are equal. So it's a cubical box. So now which big box requires the lesser amount of material to make? That is what they are asking you. So you find out the total surface area. Material to use is the total surface area, right? The whole thing, all the walls and the floor and the ceiling, everything is considered. So let's find the total surface area of a cube. Okay, that is 6L square. We already know the formula. 6 into L is 50 and L is 50 in all the cases, right? This is what is your L? So 50 into 50. So that's going to be this. You can solve and check. And then total surface area of a cuboid, you use this formula. So you substitute L is 60. So for this one, you see, this is your L, this is your breadth, and this is your height. 50 is your width. So you put whatever L, B, L, you substitute the required numbers, and then you multiply them, and then you add them, and then again multiply it with 2. So you get this answer. Okay. So now comparing these two, this one and this one, you can see that the cubical one, 15,000, is larger, right? So the materials required for cube is more. Okay. Now come to the second question. It says there's a suitcase with this measure. Okay, when they say this kind of a measurement, the first number goes for the length, the second one goes for the breadth, third one goes for the height. Okay, it is to be covered with a tarpaulin cloth. It's supposed to be covered with a cloth. Okay, a suitcase cover has to be made. And how many meters of tarpaulin of width 96 is required? They ask me to cover 100 such suitcase. So for one suitcase, you will be requiring, again, it's a total surface area of a suitcase. So you use the formula, substitute for L, B and H. Okay, these values as it is written. Okay, you substitute it and you get the answer. Okay, and then you have your total answer as this. Okay, then you have to find out, for one suitcase this much cloth is required. For 100 suitcases you'll have to multiply by 100. So these many. Okay, now they know that this is the area of the cloth required. Hold on, see this much area, whatever is the 100 suitcase area, that much cloth is required, right? That cloth is supposed to be in a rectangular form, isn't it? And they have already told that the cloth's width is 96. They are asking you what is the length. Okay, so length into breadth should be equals to this. Length we don't know, breadth is 96, so length into 96 equals to this answer. So L is divided by 96, so you get this answer. Or you can even say 144 meter, either 14,400 centimeter or 144 meter. Okay, either is. Now come to question number 3. Find the side of a cube whose surface area is 600 centimeters square. So you have a cube, and so they are saying find the side of the cube whose surface area is this figure is find the side of the cube whose surface area is 600 centimeter cube. So there is a cube whose surface area is given. So the total surface area of a cube formula, we know that it is going to be 6L square, right? So this 6L square is actually 600 given to you. So L is what they are asking you. So L square is 600 divided by 6. So L square is going to be 100. So L is going to be square root of 100, which is 10 centimeters. That's the side. Okay. Now come to this last one. Daniel is painting the wall and ceiling of a cuboidal hall with length, breadth and height of this. See, when they say this, so this is your length, this is breadth and this is your height. Okay. Now from each can of paint, 100 meters square of area is painted. Okay, so from one bottle one can, you can paint 100 meters square of area. How many cans of paint will be needed to paint the room? So first we should find how much area is there to paint the room. Then we will use the can thing. Okay, now this is the room's thing, and they are saying that Daniel is actually painting only the walls and the ceiling. Floor is nobody paints the floor, isn't it? So you can't consider it as total surface area, right? Because total surface area covers even the bottom, isn't it? So area to be painted will be area of 4 walls, all the 4 walls, and plus area of the ceiling. Area of 4 walls is nothing but LSA, lateral surface area of a cuboid, plus area of rectangle, right? So that because it's a rectangle, no? The ceiling is also a rectangle. So here lateral surface area of the cuboid, you have a formula 2HL plus B, and the area of a rectangle, which is the ceiling, see this one, this is what I am supposed to paint, right? That's going to be L and B, so L into B. Okay, so now you see 2, so I have to use the H is 7, so you see L is 15, B is 10, and H is 7. So use the formula. Okay, so you substitute it into this and you get 14 into 25 and plus 150, and you get 350 plus 150, 500 meters square. This much he has to paint. Okay, and for each 100 meters square he is using how much? He is using 1 can. Okay, so for 500 meters square he'll be using 5 cans, right? So that's what we have got. 500 divided by 100 is 5. So 5 cans will be needed to paint the room. Okay, and that's it. So now you can complete these 5 questions in your classroom. I will see you with the next video. Okay, just so inshallah I'll see you with the continuation of this exercise in the next session. Allah Hafiz. Thank you.